the release of Go 1.27 has made it possible for us to have very beautiful API as well. So we are going to transition this code from this to this in this video. And I want you to enjoy this video, because after you watch this video, you are no longer going to design API that is difficult to remember. Rather, you are going to design APIs that other programmers would enjoy, code maintainers will love you. So stay tuned and let's start coding. In this video, I want to show you that beauty which we now can produce just by changing the way we program a little bit in Go. And I am very excited about this release of Go 1.27 because this is something that I've always been waiting for, and that is why I'm making videos about it. Now, I want to show you how I am thinking about this. First of all, I have my screen here. So I have this part of the screen is my main.go, and then I have a second file here, which is query.go. Both of them are blank. Under this place is where I'm going to run my terminal. For example, I can type go run like this to run it. All right, now I'm going to close it. Okay, I like to walk backward a little bit. So let's assume that we want to do something like this. Just be patient with me. We have order. Because I am in e-commerce, this is always the example that I make. So customer, total of their order is an integer, and then if they have paid, simple struct, right? And in here, let's create a collection of this. Think about this. This can come from your repository or any source, but for now, let's hard code it in here as static values. So we create a slice of orders, and quickly here I'm going to create a bunch of them. Say add the customer name and put like 120, paid is true. Right. And then let's copy and paste quickly. I think we can do it like 4. I'm going to say Grace 80. Let's assume this customer is yet to pay. And then I can pop myself in here. 95. Let's say I also paid. And last Mike, and I can make this one 150. And also paid. So we have this collection, which is very simple slices of order. All right. Now, how do we want to operate with the data? And this is it. Each time you have data, you think about operation. That is how data structure and algorithm came by, right? We have data, and then there is something we can do with the data. So what do we want to do with the data? We may want to transform the data. You probably want to do some filtering and many things, anything you can imagine. All right. So there are multiple ways to perform the operation. So what I'm going to do, first of all, I'll create some kind of functions here, conditions that we are going to use. So inline function, I say for paid customer, I'm going to say any customer with their order, order.paid. So these are paying customer or the customer that have paid. Basically a function that return paid, true. All right. And then we have another one, which is another function that returns an order. Sorry, this one returns a string and it's going to return the customer name, which is what we call customer. These are just functions. Here is the juicy part. Before Go 1.27, this is what you are going to find in most code bases. Most times, this is what you are going to find. So what you are going to do is this. So I can say before, they are going to have like, maybe we want to transform the data, then we're going to have a map, which we are going to transform. But where would the data come from? Well, maybe we need the data to come from another place. So we can say from, pass it the data, which is orders now. So orders is going to, from is going to create sort of an instance or the values and return it to map, and then map will do something. Now map also need to return it, but here maybe for some reasons we also can add filtering to the order type directly if we want. and then we can say paid, and then we can pass customer here. This is one way to do it in before Go 1.27. You could see an API that looked like this. Nothing strange, very straightforward. We're basically filtering and then we are mapping. Mapping basically transform and return just the name of the customer. All right, for paid customer, filter by paid customer. So right now, if I run this code, it's not going to work. But with Go 1.27, now after Go 1.27, there is a way I think about it that it should be more fluent. And this is the most important part of the video. The API should be fluent, should be more beautiful. So what we can do now, we can say after, of course, we need a way to get the order. So from, so more like a constructor, this is going to return a collection. So we can say dot, we can filter, and then filter it by some sort of predicate. And then we map, we pass the mapping function or the transformer, and then we can say, okay, maybe take 2 of it and then collect. This is, for me, way easier to read, and I can just put them in a different line here. If you come to the code and you look at these 2 different approaches like you have here, so 1 and 2, honestly, you will probably understand exactly how this works, right? Look at this. This, first of all, is from the from, it goes into the filtering, then it jump out. So there is this jumping happening everywhere. And of course, we can run this through benchmark and see the performance of this approach and this approach. But that is, let me know if you like benchmarks and I can make a video. But for now, I just want to focus on the API. So we're talking about API design. The design of this API for me is more descriptive, it's more beautiful, it's straightforward, and when you come into the code, you automatically know what to do. Even during syntax or autocomplete, your autocomplete, as soon as you hit dot here, it can give you a list of options: filter, map, take, and then of course collect. So how can we make this code work? I can try to print something here. It's not going to work. So before and then after. Right now, if we try to compile it, this is not going to work because we don't have any of this implementation. Like I said, I'm working my way back. I just want to convince you. So let's run the code and boom, we have an error, which is fine. This is what we want. So let's write the code to make it work. I'm going to close this down a little bit. First, let's create a type and then T of any. It's just a simple struct. Because I don't want to write a lot, I'm going to use the iterator package. So the pronunciation is a little tricky for me, but I just call it iter. So iterator, that is what it is. So look at it, iterators. So they're shortening it to iter. So I'm going to call it the iter package. Anytime I say iter, just know that it's ITER. All right. Now we're going to use this. If you don't have experience with this iter package, please leave me a comment and I'll do a video on it. Very powerful package. The code will look a little bit confusing, but I'm going to tell you the most important part. Just a quick thing. The most important signature that you want to remember when I start working with the iter package, there is a signature for this. This one. Look at what it looks like. It is just a function that takes another function that function that it takes one value and returns a boolean. That's it. So it's just a function that takes another function that takes a value, returns a boolean. A little bit mouthful, but it's a simple and straightforward thing. All right. So the first thing we want to implement is the from, which is serving as a constructor, a factory. So let's say func from. And right now, we don't need to, it's not it's not part of the query. It is an independent function. So it's going to be generic. So I can, this type, I need to put a T here very well. And then the argument, the values, because it's going to accept, you see, with giving it the slices here. So that's why it's a slice of T. And then what does it return? It returns a query, because here, this is a query we are going to return. And then a query of T. Then what we need, we return query, and that sequence, and then slices dot values, and then you pass it the values. So I'm using the standard library to make our life really, really easy. I forgot to pass the generic along, because if you look at the definition here, you see the generic is here, so you must pass it along. All right, for the takeaway for you, maybe you will learn one or two things from this iter package I'm using, but the most important thing is the API's design. So you just want to focus on the API design. All right, we are done with the from, and as you can see, we no longer see the red line on the from. Next, we want to work on the filter. Now we are going to add the filter as a method to this. So I can copy this, and I say func, let's say query. I need to take out the any here, and then filter. What else? The keep function that they are going to use to test if we should keep it or not. That will return a boolean, and then it returns a query. Now, before Go 1.27, this would have worked, right? Because this doesn't require generic. Here, we are not requesting for generic for the method itself. The generic that we carried over is coming from the query. So this would have still worked in Go 1.26 and in Go 1.27. So this is going to work. But this is not new. This is the same old thing. It's a standard. So this is why we can do it like this here. All right. And the interesting part is because the from returns a query. Query now owns this filter. So we are able to change these two parts so far. All right. Good. The next thing is because we returning this query T here, let's return this function that I showed you earlier. So careful, it's about to get a little bit confusing because of that function, but trust me, it's not that bad. So I'm going to say query, and then I pass it the sequence, and that function that I mentioned is exactly what we are returning. So for here now, value, range query dot sequence, and if they want to keep the value, and yield has not stopped, we can return. All right. I hope I didn't make any mistake, because this thing can be error prone. Sometimes you just forget to do it properly, and then you run into an issue. Okay, then the next thing I want to show you for sure is the map, right? Now we have this tool is working, so we need the map. So for the map, is very similar actually. So I'm going to say func, and here's where it gets interesting now. Map, this map is this would work before Go 1.27. It's still the same thing like how we did one here. So func map, you see T U any, and then query T, pass along the generic, and this is a transformer which we are going to use to do the transformation. Where is this coming from? Transform, and then function T U, and that's it returns the U, then query and U. Okay. Yeah, this is the thing about generic. Because of the placeholder, sometimes it can be difficult to read, but if you follow it carefully, it's not that bad. Basically, it's a function that takes a value and then another function. That function is what you're going to use to transform it. All right. If you look at this place, internally, it's going to accept this function, then the value will be passed to it, and then it returns it. This function will accept this value here, and that's it. Okay, with this, we're going to do almost the same thing that we did up there. Return, query, right? And then sequence, function, yield. And then here's where the mapping happens for value, range, query.sequence. If the yield, the consumer, when the consumer stop, you want the sequence to stop. But we just transform, and then we can return false. All right. So we have the map. As you can see, this part is actually good. So if we want, we can run the code. So let me comment out this part, comment out this one. And I don't see any errors, so I can run the code and see. It should print like a memory address or something. Yes, so I want to do a quick cheat to show you how to print this out. I'm going to call slices dot collect, I think, and then .seq. I think they should collect it for us. Yes, you see, it collected the names because we transformed it here, right? Names of the customer that have paid. What if we want customers that haven't paid? Well, we'll come back to that shortly. But as you can see, this is working. The implementation is correct so far. So what I'm going to do, I can return this back to what it was. Let's go back to this one that is currently not working, and then we need to add the map for this. Okay, the second map that we want to implement belongs to the query. So let me come down here. We're going to reuse this, but look at the signature carefully. Just like we added theta to it, we are going to add this, but to get more interesting. Now we're going to call it map, and this is where we need Go 1.27. Because we need an additional parameter passed in as generic, this generic type now belongs to the method, not to the type. It belongs to this method, which we are going to call U. And this is why, this is actually the changes in Go 1.27. So I'm going to say any now. And with that, we can come here and say transform. Basically, almost the same thing that we did with the original one. U. And then query U. That's it. The only difference is that the map now belongs to the query, and instead of writing this code again, we can just return that implementation. So query, not that one, the query that we pass as, and then the transform function. Okay, as you can see, that is out. That one is done. We need this take. The take code is a little bit long, so let me come here and say take n. What are we returning? We're returning the query back after we have collected how many that we want. The same thing, we return that same function, query. Remember, I think by now you know exactly how it is. So the sequence, and then the same thing. All right, so how do we do it? Inside here, let's do a quick check. I don't want someone to say take 0 or take -1. So what we can do is if the n less than equal to 0, we just want to stop. We get out. We don't want to run the code. How many they want to take, let's keep track of it. So basically we are going to run the sequence, and then we return when we hit the number that they want to take. Look at this. So value range query.sequence, of course. If so, when the consumer want to stop, we stop. If not, we just count. We just sort of advance this counter, and then we check something here. If count is equal to n, we return. That would sort of help us reach where we want to reach. Now, the last thing is the collect. The collect, I already showed you how using the slices. So we're just going to do the same thing here, but at this time it's going to belong to the query object. So I can say collect. It will return, this is a terminal function or a terminal method. It doesn't return the query back. It returns us the product that we want, which is, in this case, is the slice. All right, so I'm going to be quick. The video is getting too long. So return slices. This is coming from the standard library, by the way, in case you don't know. Collect, and then we just get the query.sequence, and that's it. With that, you see that our code is looking good everywhere. We no longer have an error, and I can run the code and look at it. It gives me Ada and Joseph because we take 2. If I say 3, we should have 3. But if I say, let's say I say 5, what happens? We still get 3 because of the condition here, which is paid. What if we comment out the paid part? And this is the beauty of the way we chain this method. You can take out any of them without causing problems. We look at, then we have everyone. Or what if we want to find the customer that have paid, that haven't paid, customers that haven't paid for the order? Well, one of the ways we can do that is write a new function here, right? But we can do it inline here. So I can say func is, this is odd. It takes an order, right? Man, I can't type. So it takes an order, and then it returns a Boolean. Then here, what I'm going to do, I can say order.paid, but I am going to put a negation sign. That way, we flip the logic, and that gives us grace, only grace that haven't paid, and that's it. So this is correct. Now, and this is going to end the video, but let me do a quick recap of the beauty of what we have. Look at, we went from this to something like this. Even though this looks longer and all that, it's no problem. Of course, we can go back to what we had. Instead of, even if you don't call the take, you can call collect as it is. And it's still going to work. You can shorten it as you like. You can just call from and then just collect it immediately. But look at the flexibility. And it's so powerful that you almost can't make mistake, or it reads like English. We collect, we filter, we map, or you can do even the order we should do. It doesn't really matter much anymore. But when you are doing it like this, you have to be careful to remember the order and all that, and it's quite confusing. For example, you don't know when this map is running it, but as you can see, after this operation is returned to the map will receive the slice, and then it runs this function against it. So for me, this approach here, This is way better, and I think we are going to start seeing more of that. Thank you so much for watching. If you enjoyed this video, please don't forget to share on Twitter or X, like the video, and then leave me a comment. I'll see you in the next one.